Well, I'm going to discuss Byron Brubaker's hairpin circuit that I modified because I couldn't succeed at getting it to work under simulation, and I haven't built it. So here we go. So this is the original schematic that you can still find a copy online. I have it, and somebody else on overunity.com has it, but he used to have it on various places of his own, but he took them down. He took everything down. He kind of got upset with us. Anyway, I don't want to harp on the negative. So this is the circuit, and what I've done is I've gotten rid of this portion here, and I've gotten rid of this transformer, and I've gotten rid of the AC mains. But I kept this ground, and I kept this ground, and I kept the 4 diode bridge, and I kept 2 of these capacitors. I took out one, and I rolled it around to be in parallel with this one, so they're both in parallel with the diode bridge. So I have 2 capacitors in parallel. And then I magnified this ground by a factor of 9, so I have 9 of them minimum, and I have 2 capacitors here minimum, and anything less than 2 here or 9 here does not work. Now, amazingly, the thing works with very little help from us. So if I can find the schematic, I just got finished drawing it. Whoopsies. Uh-oh, uh-oh. I'm a little new to this, sorry. Maybe this is it. No, that's where we are. Is this it? No. Well, this is the guys who inspired me. And I think they're doing something similar because they're grounding, they got 2 grounds here, grounding to the atmosphere. Because it's a mobile power station on their electric car. And these are copper spheres, maybe they're hollow, I don't know, on copper rods in their maybe iron winding drum. This is Sierra Lamont, I would imagine. But I don't know, it could be the other guy. The other guy is his brother. One is Sierra Lamont and the other is the brother. The brother lives in, I think Sierra Lamont lives in Spokane, and the brother lives in Colorado Springs, or Denver, actually Denver. Anyway, so they gave this demonstration 102 years ago. And one of them took this, the actual engineer, took this device and his car. He drove it all the way to Washington, D.C., because he didn't need any batteries, because the whole thing runs off of atmospheric electricity and the various reactances taking place in here to make it possible to drive this electric car that is probably no different in performance than a golf cart would be in our day. So don't expect this to be a power supply sufficient for a Tesla Roadster, but it could power an electric car, electric go-kart, golf cart, and the throttle that he used probably was just an on-off throttle because that's what golf carts are. They have one speed only. So that's them. I wanted to cover them. So let's now get rid of them, get rid of him. Now if I can find the next slide here. No. Well, these are, okay, so these are derivatives, my first stage derivatives of Byron Brubaker's circuit. So I have the AC mains here, and I've got the transformer here with the 2 coils, and I got the mains ground, which he implied. He didn't specify you needed to put it in your circuit. And here's your ground that you're going to be sucking all the power from. Here's your diode bridge, and here's your 3 capacitors. And this is a step-down transformer. I got a kilohenry on this side and a millihenry on this side. I found I could reduce the spread between those to quite a degree. But I have 120 volts input and 60 hertz. Now I found I could get rid of that and scale it down to 1 microvolt input and 100 kilohertz frequency. And having a higher frequency stabilized a lower voltage and worked just fine. And this one I didn't change the, so it still has the same settings. Oh yeah, and I was able to reduce the capacitance on these capacitors from 1 kilofarad down to a farad. Although I was able to take it down to 30 millifarads, but it was a little unstable, so I think 100 millifarads or 300 millifarads or 1 farad is actually ideal for stabilization. And I had to lower this because you'll see in a minute. All right, let's move on. Let's see, I'm looking for a file. I don't know if I can find it. Oh, I got two of the same. Oh, that makes things confusing. Now where is it? Well, I might as well go to this one then. Okay. Uh, well, maybe I should cover the principle first. Okay. So the principle, I think, is the Coanda effect. And this is where you have a stream of air or water or any other hydraulic fluid or air, whatever, and you're pushing it along, and it entrains the surrounding molecules to join the parade. Hey, they're bystanders. There's no police here getting in the way, and so they just join the parade and walk through the crowd. And then these are other images on the Wikipedia article on the Coanda effect, COANDA, in which different configurations all produce the same results, similar results. Now, this is a device or a configuration for a mobile vessel in which you're forcing the air out and then you block it so that it's forced to go along the perimeter, the surface of the nose of your craft, and that creates a reduced pressure in the front of your craft that pulls you forward. And Wilhelm said this is how UFOs operate, except instead of a fan pushing air out, it's an AC device projecting a cylindrical or tunnel-shaped AC wave out the front end of your, or in the direction you want to travel, and that pulls you along, provided you shoot out the back end of DC to neutralize the AC that you've moved into, that you created previous to your moving into that pathway. And that combination of effects neutralizes inertia, which is the same as neutralizing gravity, by the way. So whether or not it's true, I don't know. That's just the luck of the draw. We don't know, do we? So we'll close out this window. And now, oh yes, Eric Dollard. Eric Dollard is an interesting fellow. I made this excerpt from him, from Aaron Murakami's posting of his video on YouTube. And it's all about Eric talking about how the utility companies defy the speed of light by putting banks of capacitors every 100 miles along the length of a very extensively lengthy transmission line. And they do it to set back the electric field so that it doesn't get ahead of the magnetic field. Because if it does, and it usually does over long distances, as was discovered by people who were working the telegraph cable, the transatlantic telegraph cable of the 1800s, so they conserved against the loss of the magnetic field by wrapping the copper cable with iron ribbon and then surrounding that with very thick insulation. And that was all due to the mathematics discovered by Oliver Heaviside that described the problem and made the suggestion of how to solve it. But that's just one way, is to conserve against the loss of magnetics. But if you want to retard the phase angle of the electric field so that the magnetic field can keep pace with it, so you don't get just voltage at the other end of the line and no magnetics, then you put capacitor banks in line, in series, in line of or with the transmission line to retard the electric field. And you do that every 100 miles. And the banks are huge. He's spreading his arms here to show these are really big. Oh no, actually he's spreading his arms to show the length of the transmission line. But he says these banks are big enough to fill 10 rooms that he was in there giving a small lecture to a small bunch of people. And it does the job. So space-time conjunction, is.gd/space-time conjunction is the shortcut I use for my little excerpt of that video. And in the description you'll see the video link that it was taken from. Now, William Line is another fellow who talks about a similar phenomenon. This is an excerpt from a very long video, um, and it's all about, he's talking about Tesla and the Nazi UFOs during World War II. They are Tesla inventions. Oh, I might as well say something about that. Edgar Casey, I mean, I grew up, kind of, looking up, shall we say, to Edgar Casey as a role model. I really wanted to believe everything people say about what he did. He went into trance and he gave psychic powers. He displayed psychic powers. He could tell what was wrong with somebody's health in a remote location if you gave him the address, and he could tell you what to do to fix the problem, and he could give you past life readings of people and talk about the past, Atlantis or whatever. And I wanted to believe it was true, and it turns out it's not. He didn't know it. He was being used. I called him, he was used by a handler, namely his brother, acting as his handler unbeknownst to the person who was being handled, namely Edgar Casey. And when he went into trance, he thought, or he was told to think, to believe that he became psychic, but it only happened when he was under trance. The truth of the matter is, his brother supplied the stenographer with a typewritten script, and she would hand transfer that, hand write it out in longhand or whatever she was using to take notes during his so-called sessions, to make it look like, she had written it taking dictation from him, when all along she was taking dictation from Edgar's brother, who in turn got that printout from the FBI, who was the sole source of channeling all that information during each of those trance sessions. So it was fraud. But it's very curious because I spent all day yesterday researching Nazi UFOs during the war, and I discovered part of their history. They had two psychic mediums who were supplying them with information. Supposedly they were mediums receiving this information from an inhabited world in the constellation Aldebaran. There are two planets encircling their sun, apparently, and it's 68 light years away. And I suspect now I know how they managed to get away with that bogus, fraudulent claim. See, they wanted to hide the fact that Tesla was the source of the Nazi technology. Most of it. They did a lot on their own, but they needed Tesla's help so badly that after they stole from him, and by hiding the theft by torching his lab in 1895, 50 years later, or more or less, a little under 50 years, they needed his help because they still couldn't figure certain things out. So from 1936 to 1938, according to William Line, you can read it all in his book, Pentagon Aliens. You can buy off of Amazon. He's no longer with us. He's now deceased. But he wrote these books and left them behind for us. And he says in there that Werner von Braun came out and was coached personally by Tesla in New Mexico between 1936 and 1938. And specifically for the neutron bomb technology that Tesla had invented, Tesla's special generator that powered a small segment of their electric U-boat fleets, giving them a 30,000-mile range, at least, minimally, if not unlimited, depending on the circumstances. What else? Neutron bomb, special generator. Oh, and of course, the UFO levitation craft. Now, Tesla had already worked out not the details, but the overall proof of concept behind anti-gravity levitation through electrodynamics while he was still at university, when he was just a young guy. And he didn't build a proof of concept until the early 1890s. And he would leave his lab. He had a lab on a multi-story building. Let's say it was the hotel he was living in. Usually he liked to do that. And then live there. He took the whole floor, and then part of it was the lab, and part of it was his sleeping quarters. So he would fly out a window at night, and this was in New York City, and tootle around and come back in. What he did was he converted a one-man potbelly stove. This is the way I read it on the internet back in 2014-ish, somewhere around in there. So that's about 8 years, nine years ago. Well, I got curious after a while because I realized UFO craft have to be made out of aluminum. And an over-unity device has two modalities, energy versus anti-gravity. Marvin Cole, who was the initial guy who working on the Evie Gray motor before Richard Hackenberger came on the scene to replace him because he freaked out. Marvin freaked out because the device started to levitate. And he left town, took all his notes, took his girlfriend, and we don't know what happened to him. And Evie Gray didn't know a darn thing about electrodynamics. He was just a used car salesman. So he hired a formally trained electrical engineer, and he couldn't figure out what Marvin Cole was doing. So he tweaked it according to the standards and conventions that he was taught. And that gave them a ridiculous overunity of power, as verified by the Bing Crosby Foundation that was started during World War II to help accelerate the development of inventions, American inventions, to help the war effort. Well, they went there they were still in operation as a third-party tester, and they found a COP, a coefficient of performance, by a factor of something like 190 or 290 times greater than input. The output was something on the order of 200 to 300 times greater. Now, I'm not talking percentile, because that would be like 20,000 or 30,000%. I'm just talking strictly factor, ratio proportionality of output to input. They had so much excess electricity they didn't know what to do with it. They kept dumping it into batteries, blowing them up, until the FCC came and raided them in their Van Nuys lab in the San Fernando Valley. That was their second raid. And the FCC was more thorough than the DA raids, the DA's office of LA County. The FCC took everything, even their desk chair, because Richard Hackenberger did not have an AM radio playing music while he was working, so he had no idea that he was putting out radio interference. And the ham radio operators or whoever, reported him, but they didn't know they were reporting him. They just reported interference, and the FCC triangulated and figured out exactly where it was coming from. So this spurred Richard Hackenberger to figure out how to stop doing what he didn't know he was doing. And not only that, he figured out he didn't have to blow up batteries anymore. It was a beautiful system. They forced air through the interior of the device. They made some other changes to turn it into a capacitor. But the air was part of that dielectric material of that capacitor that he set up. The whole motor and its casing acted as a capacitor of sorts. And the moving air was part of that dielectric medium that became ionized, and then he was moving those ionized charges out of the device into the surrounding space. They were no longer electromagnetic waves of any intensity to worry about. They were now ions, molecularly charged molecules of air that grounded themselves out over any object available, people, walls, ceiling, floor, furniture. And so it was a safe way to prevent radio interference. And if you don't want the FCC at your door knocking away, you'll want to do something similar to protect your environment from the disruption that you'll be creating. Because more often than not, over-unity devices exhibit a very highly elevated field of electrostatic voltage. It's hard to avoid it. And in that elevated state of electrostatics, there you have some differences between them, creating electromagnetic movement, and that's where you get your power gain. If there's not much or any difference between points in space of voltage difference, you're not going to get any gain of power because you don't have any movement. You just have a static field just hanging there. But it will elevate itself from ground potential, and it'll elevate itself so much so that anybody else in the environment nearby will recognize the field and its intensity as a disruption, and they will report you. So, now I've kind of segued here about UFOs. I've kind of gotten ahead of myself. So we solved it, so maybe now it's time to get into UFOs. So let's go back to, let's see, where is it? The schematic. So, what I put here, I typed up and put down here on the right-hand side is, I'll read it to you. If you're going to design an anti-gravity craft, you'd better make sure it runs on free energy, since UFOs are very inefficient, not efficient, at their utilization of energy. They waste a tremendous quantity of energy to neutralize inertia, aka gravity, since there are no motor coils from which to recover reactive power upon turning off the power supply of a UFO craft. Instead of coils, a UFO craft uses high voltage electrostatic fields surrounding their craft to substitute for their lack of coils. This is why Wilhelm Reich was able to crash a UFO by accidentally pointing his cloudbuster tubes at a cloud within which a UFO craft was hiding. Since the humidity was above 70% and the ions of air immediately surrounding that craft was of positive polarity. These are the classic symptoms of a smoggy day in Los Angeles or San Bernardino counties. Into this high voltage electrostatic field is projected the electromagnetics which are necessary to neutralize inertia and gravity. But if this electrostatic field should disappear, then its UFO craft will come crashing to the ground. This is what got Wilhelm Reich arrested, put into a federal prison. All of his books were banned in the United States. I could be in foreign countries as well, I don't remember. And he never made it out alive from prison. He was murdered by an inmate just before his release. Now, the electrostatic field is the substitute for motor coils. Anybody who knows anything about motors, you turn them on, it takes a certain amount of energy to charge up the coils. Now that's additional energy you don't get to spend. The energy is there in the coils, and it also bounces back and forth between the coils and the source of energy, let's say the battery pack of your EV, and it stays in the circuit, but you don't get to spend it. But you need it to charge up the coils, or else they won't run. Now, you're also, in addition to that charging energy, you have an additional amount of energy that's very small, and that's the energy you actually spend. You actually waste it. You throw it away back to the battery pack, basically. Some of it converts into heat, but most of it goes back to the battery pack, neutralizing the potential difference between the two terminals of the battery pack. But that's the energy you spend to run your motor and turn the coils and get your car, to move forward or backward or whatever. Now, when you turn off your car, the reactive power you had used to charge up the coils now returns back to your battery pack, which again neutralizes the voltage differences, unless it's, well, I don't know. I don't know if it neutralizes or if it goes back and recharges the battery pack. So I'll leave that alone. I don't know. But it goes back there, one direction or another, to the battery pack. Now, we know this, you know this, because when the compressor motor in your refrigerator kicks on, if you have poor wiring in your home, and my mom's home had that, one of them, every time the compressor in the refrigerator turned on, the lights in the house would dim. But they would dim drastically, but only for a short duration. They'd gradually come back up to full strength. What that shows, it indicates that the power that would have gone to those light bulbs was being sucked like crazy by a hungry compressor electric motor that just needed that electricity so badly because it was trying to charge its coils. You see, unfortunately, unlike an EV, a car like a Tesla Motors car, the compressor in the refrigerator is fed a constant stream of wattage. It doesn't have a motor controller giving it variable quantities of wattage to accommodate the various stages of its behavior. So consequently, in the initial parts of turning on the compressor motor, when it turns on to circulate the coolant, or the refrigerator coolant, there's so much drain on the electrical system because it's struggling to charge the coils before it can even start rotating the drive shaft of that motor. So once the coils get up to speed, it slacks off its drainage of power from the grid, from your house mains, and now your electric lights can go back to normal brilliance. Well, so this shows that the reactive power is a very real phenomenon that electrical engineers already know about. I'm just, explaining it to you in case you know nothing, that this is one way to see that what I'm describing is something you've already been maybe making note of, but didn't pay attention to, let's say, or didn't have an explanation for it. Well, When you have a UFO craft, there is no coils to charge. All you have is your environment immediately surrounding the craft. You have to dump a tremendous amount of electrostatic force into the environment immediately surrounding that craft to serve as a substitute for the coils. And once that field is there, now you can use in a projection of electromagnetic dynamics to create the anti-gravity or anti-inertia response so that your craft can make right angle turns. It can start up on a dime and immediately go to 4,000 miles an hour, or stop on a dime, or make right angle turns at 4,000 miles an hour without curving to have to do it, just changing a just a right angle turn with a sharp edge to it, that right angle turn. And they can do it because they're neutralizing inertia using electromagnetics. But in order to have those electromagnetics not leak away, which is what they discovered in the transatlantic telegraph cable of the 1800s, they had to protect from the loss of electromagnetics somehow or another. Well, the way the UFO craft does it is by creating this very highly intense voltage of an electrostatic field to protect against the loss of electromagnetics. Okay? Now, I say all this because, why? Well, as an illustration of how important it is to try to understand how circuits work under different situations, depending on what kind of circuit you're dealing with. And I know enough to know how to extrapolate from what little we know about UFOs that that's a precondition that has to be there. And it's just plain logic based on simple facts that electrical engineers already have at their disposal. You know, a beginning student of electrodynamics would already know all the facts necessary to come to that conclusion if they want to posit the thought, oh, maybe UFOs are real, regardless of who makes them. Now, I've already covered the point that they're not alien because those psychics feeding information to the Nazi party were fake. They just wanted to hide the fact they already had stolen the knowledge from Tesla and then had Werner von Braun as his tutor, as one of his tutored students for 2 years immediately prior to World War II. So they got all they needed from whatever they could figure out, but a lot of it came from Tesla himself. Tesla gave it to them because, well, frankly, we thought he was a kook. Our government thought he was a crackpot and didn't pay any attention to him. Tesla wanted to share all this information with our government, but our U.S. military, but they weren't interested. And it's probably why they were down the hall from his hotel room prior to his death, waiting for him to die, because so many stories had come back about Foo Fighters during the war that they finally figured out how valuable Tesla was. But he was too old to be a threat to anybody, so long as nobody got a hold of him, and so more importantly, so long as nobody got a hold of his papers, his documents. He was using his hotel room as doubling as not only as a living space, but as a warehouse of all his documents and safes and whatnot. So yeah, they came in and took everything because they didn't want anybody else to have it. Makes sense. It's the middle of the war. Anywho, so Byron, this is my modification of Byron's circuit. Now, over to the left here, I'm going to read you what it says here. There is no limit to the number of various loads on the left-hand side. So I've got 4 loads here, only 3 of which are true loads. And I got one of each type. I've got an inductive load over here. Here's the inductor coil. And I wrote there 10 henries, but it can be far higher than that. You'll see in a minute. Then I have a resistive load here of 10 kiloohms. And then I have a capacitive load here of 1 kilofarad. Now, what I have over here is a drain. Now, you don't need any of this. You could just have the rest of this, and this thing will build up voltage up in this area, and it'll bleed down into this area, and the thing will blow up anyway. And you can put all these grounds here as an option to try to create a situation of current flow to counterpoise all this voltage that's building up. And then you put your loads down on these. Each type of load has to be on its own grounding branch. These are all in parallel with each other. You don't want to mix them. You could mix the inductive load with the capacitive load, but I wouldn't recommend mixing anything. Keep them all separate, and keep your drain, separate from all of the other loads. Now your drain is simply that. It's got a simple resistance on there. Initially, I just used a solder joint resistance of 1 milliohm, but I found that when I raised the impedances of these three types of loads, I needed to raise this as well to stabilize the behavior of the overall behavior of the entire circuit. And I found that 1 kilo ohm on this drain works just fine and dandy. Now you'll notice it has a diode here. All of these 4 diodes are not required. They are optional. All of these 4 spark gaps up here are not required. They're optional. These are simply enhancements to boost power. On the load branches, the diode, the triangle, has to point in towards the circuit and away from ground. Meanwhile, the drain, it does the opposite. It points away from the circuit towards ground. I put in my simulation work, I decided to modify. Microcap only gives you one type of spark gap, and they call it a spark gap, which is really weird. It's a neon bulb. It's not a spark gap. A spark gap is like what you have in your car, you know, igniting the gasoline, which is an air gap. And so an air gap has different characteristics than a neon bulb gap because it's neon gas instead of air. So I took some guess estimates as to what those changes would be, and in microcap they allow you to create your own macro. Certain things I don't know how to create them, like inductors and capacitors. It's written into the software. But extra things like spark gaps are considered extra by their software, and so they have a circuit of capacitors and resistors and inductors and digital logic to mimic the behavior of a neon bulb spark gap. And all you have to do is take that and modify it and save it under a new name and then compile it into the software so the software can recognize its existence. You give it a place, position on their menu for components, and you give it a symbol, blah, 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 and lo and behold, you've got a customized spark gap. And I've done extensive work in customizing spark gaps, so I have all kinds of spark gaps that behave so fantastically outlandish that all you need is a coil magnetically coupled to the spark gap, and you've got yourself a virtual over-unity device in which the coil generates current without having to move it through a magnetic field. Well, here we're generating power without having to do anything similar because, well, first of all, there's no coils here. The power area are these capacitors up here, these 4 diodes, and then this ground, this connection to ground, using very low capacitances. Now, the Earth capacitance is quite high. Depending on who you listen to, if you listen to convention, it's around 710 microfarads. Meanwhile, it has a voltage potential of 1 microvolt. It's actually a little more than that. It's about up to 5 microvolts. It varies. And you can run a crystal radio set from the 1920s off of that couple of microvolts. Well, that's at ground or near ground. Excuse me, but the capacitance of the Earth, people conventionally claim, because they assume it's a solid sphere, and then to do computations using concentric sphere calculations, their second sphere is infinite diameter from the center of the Earth, and then the inner sphere is the Earth, whose radius is 6,000 kilometers. So that's 6 million meters, 6.34 or 37 million meters, something like that, megameters. And if you use that, then you have to select what's your dielectric constant. Well, I had to look up. Oh, this is fascinating. I should have gotten the schematic to show you. But it doesn't really require one, so I'll just describe it. I went looking for the dielectric constant of the Earth. Well, it doesn't exist. You can find tables for the dielectric constant of mica, glass, air, vacuum, water, because these are considered to be conventional materials that can serve as dielectric material to go inside the middle sandwich area of a capacitor in here between the 2 conductive plates. Why don't we expand that? Expand it some more. Oh yeah, that's Kate Bush's tribute to William Reich. That's a nice YouTube video. It's very nice. I like it. I love listening to it. So here you've got your capacitor, and here you've got your ground. Now these are adjustment capacitors. I found I had to put them in to reduce what the circuit sees up here connected to this so that it blocks the circuit from seeing the capacitance of the ground. Instead, it only sees the capacitance of these capacitors. I call them adjustment capacitors. Yeah, see, adjustment capacitors. And they have a minimum, or actually a maximum, of 100 femtofarad. Now, 100 femto is 1/10 of a pico. So 1/10 of a picofarad is the maximum you want to make these capacitors. It just turns out, by silly accident, that you can't find a capacitor of that capacitance off the shelf to go and purchase it. Gee, I wonder why. To discourage people from accidentally stumbling into overunity, because if you want to get a capacitor to give you overreactance, and by the way, I call it overreactance, but I discovered recently there's actually a scientific article on Wikipedia called Foster's reactance theorem. That's Foster, the name of the guy, Mr. Foster, F-O-S-T-E-R. Foster's reactance theorem. And in that article, right up there towards the top, third paragraph, it's got a line that says this allows for negative impedance. Now, negative impedance is the opposite of positive impedance. Positive impedance is your enemy, but negative impedance is your friend when you're dealing with overunity circuits, because it's going to give you power instead of taking it away from you. Anyway, so to get a capacitor to overreact, you have to usually reduce it so that it will overreact. Now, Microcap, in their help file, Microcap is the simulator that I love to use the most of all. It's part of the Berkeley Spice family of simulators. The other members of that family are P-Spice, NG-Spice, what's another one? LT-Spice. And Microcap is nice because, well, for various reasons, one of which, in their help file, they give you some pointers. Oh, if you're having trouble with your capacitor, maybe the problem is you had too low a value for the parameter of the capacitance of your capacitor. Maybe you got to raise it a little, because, you know, capacitors have to be shock absorbers, and you have to have enough capacitance there to act as a shock absorber. Well, guess what? That's convention, because they're trying to get you to use a capacitor for the purposes of stabilizing the circuit in question that you're dealing with. And normally, for instance, I'll give you an example. People who manufacture motors, very often they'll put a capacitor across the two terminals of that motor coil in parallel with it to absorb the voltage created by the back EMF so that it doesn't build up on the coil and create congestion and create resistance on the coil that wasn't there to begin with. Additional resistance. So you put a capacitor there in parallel connected to the two terminals of that motor coil to take the voltage off the coil onto the capacitor, and now your coil is singing pretty because it doesn't have all that extra inductive impedance anymore, because it's been transferred to the capacitor. Now it's voltage stored in the capacitor. So, but I found through the many years of, the half a dozen years of working on simulators, it trained me to understand that if I have capacitors of low value, it overreacts. Now, what does that mean? Well, if you look up the dielectric constant, I was looking for bedrock and I decided to look up granite. Before I found the figure for granite, I found a website talking about the geology, it was describing the behavioral characteristics of the dielectric constant and said, hint, hint, guess what? The dielectric constant is the square of the refractive index of non-magnetic materials. In other words, if you've got a prism made of plexiglass and you're shining light through it, it has a certain refractive index. You've got a swimming pool and light is coming through. You know that light is going to bend because of the refractive index of the medium into which that light has entered, be it the plexiglass prism or the water of the swimming pool. Well, guess what? The dielectric material in the middle, sandwiched in between the two conductive plates of a capacitor, all capacitors, without exception, is a refractive material. Because all you have to do is take the dielectric constant of the material. Let's say it's some kind of plastic they use, you know, very often in capacitors. Thin film poly something, you know, plastic, polyester or polyethylene, I don't know, some kind of plastic. You take the dielectric constant and take the square root of that dielectric constant, and it gives you the refractive index of that dielectric material. So this is very important because it does not become significant until you have a capacitor of very low capacitance, which is what? A very thick dielectric material. If you keep the square area of each plate the same, the only way to reduce the capacitance is to increase the distance between the plates. And that reduces the capacitance of your capacitor. And that makes it less of a shock absorber, less likely to absorb and then with a certain delay discharge under the right circumstances the voltage that it had previously absorbed. And so it can no longer act as a shock absorber, because a shock absorber is really a cover term for two things happening not at the same time but in sequence, namely the charging of a capacitor and its subsequent discharge. And so that's what shock absorber means when the people who wrote up the microcap help file were intended you to convey the idea to you that, oh, you got to raise your capacitance. Well, I want to lower it to get over reactance and negative impedance and cause the refractive index of this dielectric material to act more like a prism and less like a capacitor, because I want the energy to go right through it. Excuse me. We're told capacitors you can't pass energy through because that's a barrier reef of insulation. Duh, 90 degrees to the pathway of current flow. So the current all bottles up on one plate and can't get through, but it charges up the dielectric material. You could take away the plates and replace them with fresh new plates, and they'll have the same charge as before. It'll register there in the plates, but it's stored in the dielectric material. This usually is not taught to beginning students of electrical engineering, unfortunately. Anywho, so the refractive index of that material matters because it's actually going to allow a portion of the energy to pass through. But guess what? Because it's an insulating medium, it doesn't allow real power to pass through, duh, but it refractively allows for imaginary component of reactance, of reactive power to pass through, and the real power gets stored and then released back in the opposite direction. So we've literally split the wave by converting a portion of it under low capacitance into an imaginary value of reactive power that then passes out the opposite side. But because it's reactive, you can't measure it. But it's stored in the circuit as reactive power. Okay, and that stored value of reactive power builds up. And when it meets up with positive impedances and positive resistances, it converts into real power because it gets squared. The imaginary portion of a complex enumeration of reactive power gets squared and becomes negative watts, which is the definition under passive sign convention of an active generator. Even though we're using passive capacitors and passive coils and passive diodes to generate all this stuff. Well, have I covered enough? I've gotten so off track I forgot where I was before I got to this point. But I needed to cover this so you understand how capacitors work and why these have to be low values, because you're trying to create a lot of reactive power that's going to pass readily through the dielectric medium, the dielectric material of these capacitors back and forth, back and forth. It's not going to pass through the earth very well because the earth has a very high capacitance, so it's going to get absorbed into the earth and bounced right back out again. But here it's going to pass back and forth with the greatest of ease, and each time it passes, it will split. Some of the energy passing through will become more reactive power, while the remaining real power will bounce back and go in the opposite direction. And so just by every oscillation, every half cycle, the reactive power and the real power is attempting to pass through. The real power will get blocked and come back the opposite direction, while the reactive power will pass through it and meet up with reactive impedance and simple resistance and turn into electricity and build up eventually and blow up your circuit. This is the principle by how I do what I do. And I'm telling you how it works scientifically. We now have a scientific explanation for how this works, and I'm glad to share it with you. So let's go back to a smaller. Okay, now this capacitor here has to be here, and it's along this trunk. Here we have all these dendritic branches, the roots of a tree or the branches of a tree, but here we have a capacitor on the main trunk that all these parallel branches are connected together, meeting up to go through before we come back to the DC side of that circuit up above. And I find that the best capacitance is around a picofarad, give or take. Now, all of these capacitors here and this capacitor here, I found the best optimal value to be 3 ohms of equivalent series resistance. Now, since a capacitor blocks real power, we can't say it has series resistance like we can say on a coil of wire has series resistance. You know, based on the length of that wire and the wire gauge, will get, and then you look up in wire gauge tables what the series resistance is for that length of wire based on its wire gauge and its length, and it'll tell you the total ohms. And then you go and measure that length of wire with your meter, and you find out how much it's in compliance, the table is, with your measurements. Now, when you go and wind that wire as a coil, you now have additional impedance, but as inductive impedance. It's not simple resistance anymore. But when dealing with series resistance, when it comes to a capacitor, because you've got a dielectric medium in between blocking the flow of real power, you can't really measure resistance. But there is a resistance nonetheless, and it's called equivalent series resistance. And you can look up tables of equivalent series resistance for the various dielectric materials on Wikipedia. And ceramic capacitors, I think it's down around in the range of 10 milliohms for ceramic capacitors. But if you get up into tantalum and aluminum, you can go as high as, I think, 10 ohms. And so I always use 10 as my upper boundary limit. Now, there is a patent that Byron Brubaker told me about a few years ago that Tesla is still in the public domain. It has not been sequestered under highly classified status, so we can go and view it. And it talks about the manufacturing of condensers and coils. Now, in those days, they didn't call them capacitors, they were called condensers. But be that as it may, Byron believes that it's not merely a technique intended for the manufacturing of capacitors and coils. He believes what happened in Tesla's pierced arrow demonstration of 1931, he didn't have Peter Savaro along as a companion. He couldn't stand the guy. The guy was a groupie looking to steal from Tesla any chance he could. And Tesla knew this because he knew everybody was stealing from him, because he knows why the lab fire happened previously in 1895 to cover the theft. Because no sooner than that arson occurred, Carl Linde, Linde of Germany, patented the very same liquefaction of air that Tesla was working on but had not yet filed a patent on it. And so Carl Linde beat him to the punch over there in Germany. And so we know that it was arson to hide the theft of technology, that they went in there and took what they could and destroyed everything that was left remaining. And that really set Tesla back a bit, because he was working on some coils that had 50 miles of winding on his special generator, and he never pursued his special generator ever again, except to coach Wernher von Braun in the 30s, what he needed to know to help him figure out how it ran. I figured out how the piston works. It's similar to a reed in a wind instrument, but be that as it may, so let me get back on track here. So equivalent series resistance is something you have to figure on. And one way to raise the equivalent series resistance beyond what the materials of the dielectric material of the construction of your capacitor will allow you to possess in the behavior of your capacitor is to pressurize that capacitor. And this is what Tesla had Peter Savaro along for, to pay attention to a pressure gauge on the dashboard of the Pierce arrow so that the pressure doesn't vary outside the parameter that it was supposed to safely be within that window of safety for the functioning of the circuitry and for the safety of the occupants driving the car in case it should blow up, but also in case if it should dip, then the circuit may not work properly anymore to power his car without any batteries. And I found that when I did things under extreme simulation requiring a very high equivalent series resistance, shortly after Byron told me this, I tried to put it into effect, and I found I had to raise the equivalent series resistance. And so in my mind, I was imagining that that particular capacitor was highly pressurized, had a high pressure applied to it, so that it would give me an elevated equivalent series resistance. But here, I don't really assume that. I just assume you're going to select materials that are available that will give you the equivalent series resistance that I'm specifying. So an elevated equivalent series resistance, the purpose of that is, well, one purpose that I know of, is if you're dealing with high voltages. So a ceramic capacitor has such a low equivalent series resistance because they don't expect you to pass a whole lot of wattage through those things and fry it thereby. But if you are going to pass high elevated wattage, you better have an elevated equivalent series resistance so that you don't have a boiling capacitor at your hand that you have to keep replacing. So these down here can have to be 3 ohms, while, oh, look at this. I can do this with the roller, the wheel on my mouse. While these 2 capacitors have to have 10 ohms of equivalent series resistance. And so what happens is, I assume that the Earth, so here is the Earth, it has a capacitance of, I'm assuming 1.25, 1.24 terafarads. That's 12 place values to the left of the decimal point, not 700 microfarads, which is 7 place values to the right of the decimal point. So I'm assuming a capacitance that's easily could be said to be, what is that, 7 plus 12? That's 19 place values of ratio difference between my calculations and conventional wisdom. Oh shit, I'm sorry for the noise. I hate this interruption. Oh, there we go. So, okay, we're doing all right. So, where was I before my lights got distracted? Oh, so I got the earth capacitance down here. Now here doesn't matter. I don't need correcting capacitors because there's very little influence on the circuit, its over unity behavior, because in fact you can take out these 4 ground branches and it'll still amass lots of voltage up here coming from here. But but I do want to put it in there for realism, and I simulate it, and it's fine. It does detract from the over unity a little bit, but the fact that this thing keeps growing to infinite gain and explodes itself is hardly an issue to worry about. Now, in the beginning, what I did was I didn't have these 4 drains here, and I studied all the components, and I found that these 4 diodes were generating power, and everything else was consuming power. So these 4 diodes were generating negative watts. But when I added in at least 1 ground here, the drain, all of a sudden these 4 diodes stopped generating power, and then I had to look elsewhere for where was the power coming from. And so I did an experiment, if I can find the graphic readily enough, and here it is. And I put diodes on all of the branches, both on the left side and on the right side. And I flipped them top to bottom to find out what's optimal. And then I looked at the power gain. Oh, yeah, but first I had to educate myself on the labeling of a diode, because I'm not accustomed to using diodes under simulation, so I don't have it pressed in my memory, you know, what are the labels. So if we zoom in here, oh wow, this is so easy using the wheel on the mouse. And so here's the cathode end, which is the pointy end of the diode symbol, and that's negative. So I kept mixing everything up. I kept thinking it was positive, but it's not. See, N for negative. And by the way, you can make a capacitor out of 2 diodes either facing each other or facing away from each other, and that gives you either a, let's see, if they face towards each other, these triangles, you have one here and then you have another one here facing this way, then you have a PNP capacitor made from 2 diodes. If you have them facing away, you have an NPN. And so literally without that 3rd terminal on the top that would turn it into a transistor, regulating this gate down here to turn the gate on and off, you actually have a capacitor. Ain't that cool? And they used to do this, I would suspect, 100 years ago, because they could make diodes without vacuum tubes. Before vacuum tubes came on the scene, they made diodes out of borax or baking soda. they would take an anode made out of aluminum, a cathode made out of something other than aluminum, usually iron or copper, and then immerse them into a vat of solution, a water solution of either baking soda or borax, and they would have them, and then send AC through that, and the AC would condition the anode, the aluminum anode, to develop a layer of aluminum oxide on the surface, and then that changed the behavioral characteristics, forcing the object to become a diode. And this was the configuration. They had aluminum back here on the anode side and copper or iron electrode on the cathode side. Anywho, so I have to keep doing this to remind myself, or else I forget. Oh, well, that's what I get for not being formally trained. So I discovered the optimal direction. And then I did a readout. So we go to the readout, and this is what I found out. So here we have the resistive load, the voltage, the resistive load, the amperage, and the explosion is going in the negative direction away from the midline. Likewise, the inductive load is going downwards in the negative direction, and the capacitive load is also going downward in the negative direction. Meanwhile, the drain is going upwards in a positive direction, and one diode I selected out of the array of diodes representing the Earth, the explosive power is going downwards in a negative direction. So, if we just assume for the point of memory, when I flip back to the other schematic, what is happening is that the explosion of power is proceeding in a negative direction away from midline in all of these cases except for the drain, which is going in a positive direction of numeric value. All right? That's what this is telling us. This has no awareness of what the diode is in the circuit. All it knows about is a positive number or a negative number. So now we have to take this knowledge and transfer it to the schematic to see what that means, to interpret what this is telling us. And so we remember everything is negative except for the drain is positive. So we go back. The drain is positive, okay? So we go back to here. So where's the drain? Here's the drain up here. So here's the anode that's positive. See? Positive anode. That's facing the circuit, and the negative is facing away. Well, what did we say? I already forgot. I have such a short-term memory. The drain is the only one that goes positive. So we go back to the schematic. Nope, wrong one. And it's going to the anode, so it's approaching the circuit from the Earth. Okay? So the energy is traveling into the circuit from the Earth. Meanwhile, everything else is negative. Well, all the other diodes are reversed. Instead of pointing away like this one is, it's pointing in towards the circuit. So when it goes negative, now it's still coming in to the circuit on every other branch. And I had to put them this way. You don't get to flip it and say it's just as good. It doesn't work. You'll be blocking the energy flow so severely that it'll get a comatose condition. And this might be one way to turn off the circuit. It doesn't turn it off entirely. It's still running, but it's comatose. It's like milli values of power, or voltage or amperage, if you can figure out how to do that. But that's one. So I put them in. Now you don't need these diodes on the right-hand side. In fact, they actually diminish your power so severely that you don't want them there. So you have to take them away. It was just for the purposes of finding out which way everything is flowing, so I can figure out, oh, this circuit is taking energy from the Earth, or it's generating it from the full diode bridge over here, or it's doing both. We don't know. I don't know. There's no way to know. It's just the luck of the draw. There's no way to know. So let's move on. Let's get out of... So these capacitors have to be 2 minimum or more. And these branches of grounds with their adjusting capacitors have to be 9 or more, in parallel down here and in parallel up here. These spark gaps are extra credit. You don't need them. They enhance the power gain. And these 4 diodes are extra credit. You don't need them. They are not required. They are an enhancement for power gain. So let's close out this window and see what we got left remaining. Oh, well, we have them. We don't need them. Ah, yes, the last thing to talk about. Well, I just closed out the window, but as you recall, the Amman brothers had two copper spheres. Now, in the early days of the development of the Hertz dipole oscillator or the Hertz spark gap transmitter, he had two plates. The Amman brothers have two spheres, and in this case, we know there's a spark gap in between them. We don't know what was in between the Amman brothers. All we know is they had copper tubes, and that's it. Well, I suspect they had a spark gap. Why not? And then a coil underneath. Why not? But this is a dipole antenna. Now, Marconi went and developed it gradually to the point that he figured out one of those plates, he sticks it in the ground. And now he has a monopole antenna that's grounded to the earth, and he continued to develop that. So a non-grounded dipole antenna can be, such as what the Amman brothers were using on their vehicle, can be converted into a grounded monopole antenna, and you get better power gain that way. But, you know, if you've got a car running around, you don't have a choice. You have to use a non-grounded dipole antenna because you're going to have to get your energy from somewhere, right? You have to have a reference. And so rather than being able to use the Earth as your reference, you have to use the atmosphere. And that's why the Amman brothers called their device an atmospheric or cosmic generator. Now, let's see if I covered everything. I think so. I think that was everything. So that completes my little dissertation. I hope you enjoyed it. And Mazel Tov, have a nice day. And be good to one another.